Okay, hi. This is the introduction of Lab 6. Power is defined as the work performed in a specific time or simply rate of doing work. Electric power is defined as the electric work done or electric energy dissipated per unit time. In case of DC circuits, electric power is the product of voltage times the current. In case of AC circuits, electric power includes power factor along with the product of voltage and current. In DC circuits, voltage and currents are in phase and hence power is the product of voltage and current. In these experiments, we will measure the power for AC circuits with single phase load and also DC circuits. The purpose of the experiment is to learn method of measuring DC and AC single phase power using a wattmeter, and also to learn the power factor analysis from AC single phase power measurements. The electrodynamometer wattmeter is used to measure power. It has two types of coils, which is fixed and the moving coil. The fixed coil is used to measure power while the supply voltage applies to moving coil. Okay, I'm going to show you the simulation for activity 1. This is the voltage, DC voltage source with 60 volt value. Okay, this is 60 volt value, and besides it, parallel with the DC voltage source is the voltmeter. We want to calculate the volt, and that is the ammeter. We want to calculate the current. Okay, and then it will connect to the wattmeter. Okay, after that the other side of wattmeter will connect to the resistor. Okay, this is the resistor. Its value will change from 100, 200, 300, 400 and 500. Okay, after that the negative pole of wattmeter will connect to the ground, and the positive pole will connect to the circuit. Okay, after that we will do some simulation. Okay, the first value for resistor is 100 ohm. Okay, and then we run the program, and then we get the answer in the meter, voltmeter, ammeter and also wattmeter. Okay, the next one we will use 200 ohm. Okay, after that we run the program. Okay, and then we can see the answer in the meter. Okay, there is volt, 60 volt, ammeter, and also wattmeter. Okay, the next one is we use 300 ohm value for the resistor. Okay, resistor. Okay, and then we run the program, and then we get the answer. Okay, we get the power for 300 ohm. Okay, we stop the program, and then we change the value to 400. Change the value to 400 ohm. Okay, and then we run the program. Okay, we can get the answer for R equal to 400 ohm. Okay, and last one we will continue with 500 ohm, R equal to 500. Okay, and then we will run the program. Okay, see, we can see the answer for R equal to 500 ohm. Okay, we can see it will run smoothly. We are using the Proteus software to run this circuit. Okay, this is for calculation for P calculated. Okay, when we want to find P calculated, so the formula is simulated current I times simulated voltage V. So for R equal to 100 ohm, P calculated is 35.9 volt. For R equal to 200 ohm, P calculated is 80 volt. For R equal to 300 ohm, P calculated is 12 volt. For R equal to 400 ohm, P calculated is 9 volt. For R equal to 500 ohm, P calculated is 7.2 volt. Okay, the next one is calculation for P calculated minus 3% error. Okay, to find the P calculated minus 3% error, we use formula P calculated times error per 100 minus P calculated. Okay, for P calculated equal to 35.9 watt, the answer for P calculated minus 3% error is 34.82 watt. Okay, next one is P calculated equal to 8 watt, 18 watt. The answer is after 3% error, the answer is 17.46. For P calculated equal to 12 watt, the answer after have 3% error is 11.664 watt. Okay, the next one is for P calculated 9 watt. After having 3% error, the answer is 8.73 watt. For P calculated 7.2 watt, after have 3% error, the answer is 6.98 watt. That's all. Okay, this is for the discussion for this experiment. Okay, in this experiment, we want to measure power through DC circuits. DC voltage source that we use is 60 volt. The resistance for this experiment that we use is 100, 200, 300, 400 and 500 ohm. The simulated voltage for all simulations with different resistance are the same. It is because the DC voltage source is parallel with the voltmeter. To find the calculated power P cal, we use formula P cal equal to simulated current I times simulated voltage V. For R equal to 100, the simulated current is 0.60 ampere while the simulated power is 35.9 watt, same as calculated power. For R equal to 200, the simulated current is 0.30 ampere while the simulated power is 18 watt, same as calculated power. For R equal to 300, the simulated current is 0.20 ampere while the simulated power is 12 watt. For R equal to 400, the simulated current is 0.15 ampere while the simulated power is 9 watt. For R equal to 500 ohm, the simulated current is 0.12 ampere while the simulated power is 7.2 watt. By considering 3% error due to environment, we get new calculated power as seen on the table. Okay.
Hi, Assalamualaikum. My name is Nur Amira binti Saimi. So now I will explain about the simulation for activity 2. So for activity 2, we need to boot the circuit connection for power measurement in AC circuit by using Proteus software. So first we need to set up the AC voltage supply, which is we use alternator. And then we add the resistance for load. And then we set up for the AC voltmeter and also for the wattmeter to measure the power. And then we add the ground. And then we connect the wire for the circuit. And then we set up the value for AC voltage supply, which is the amplitude is V peak is equal to power of 2, square root power of 2 multiply with the VRMS given, which is 100, and then we get the value is 141.42, and then the frequency is given, it is 50 Hertz. And then for resistor for load, the value given is 100. Okay, we set up the value, and then we run the simulation. So the voltage is 100 volt, and the power is 100 watt. Same as the calculated value that we calculate manually. Next, we can try for the others resistor load given, which is 200. So we run the simulation. So the simulated peak voltage is 100, and the simulated real power is 50 watt, same as the calculated real power watt in 50 watt. That's all for me. Thank you.
Hello. Now I'm going to present about activity 3. So the first question is create a circuit connection shown in figure 6.4 in simulation software. So this is the figure. Now, okay, this is the simulation that I did in Proteus. So then the next one. So next one is set AC voltage supplied to 100 voltage peak and 50 Hertz. So this one, so I already then number 3 is for each of the load value given in table 6.3, calculate the impedance value using the following mathematical formulas. So this is the formulas, then this is the this one is the one I solved the equation. So first is 2 micro F Xc 1 over 2 pi times 50 times 2 micro equals to 1591.55 ohm. So this one we must do 2, 4, 6, 8 and 10. Then the next one is we must use the next one we must use 100 ohm plus 2 micro F. So the first equation is Z equals to square root 100 square plus 1591.55 square equals, then we must calculate it and we will get 1594.69 ohm. Then for theta equals to tangent negative 1 1591.55 over 100, so we will get the answer as 86.40 degree. So this one also we must do for all the equation that we have. Then number 4 is the table. We must get the value from the Proteus, from the simulation. So this is the table. So number 5 is calculate the power factors using equation 1. Briefly explain your observation and finding from this step. So this is the solution. 100 ohm plus 2 micro F. So PF equals to 0.20 divided by 3.19 equals to 0.064. So we must do this for all the so we must do this like this. Then so the discussion for this exercise 3 is we get the exact value of resistance RL is 100 ohm used for every 5 floats. The value of the capacitor is different for 5 floats, which is 2 micro F, 2 micro F, 6 micro F, 8 micro F and 10 micro F. We can see between the capacitor and the power, especially the power factor. The power measurement from above, we see that the higher value of capacitor produced the higher value of apparent power and real power. So for example, the 10 micro F of capacitor make the circuit have a bigger value of apparent power and real power compared to others. So the capacitor also affects the calculated value of the power factor because the capacitor helps improve the power factor. So the higher the value, so we can conclude that the higher the value of the power factor demonstrates more efficiency than the lower value of the power factor. So that's all from me now. My next groupmate will present the next part. Thank you.
Hi, Assalamualaikum. My name is Nasnia Zira binti Mustafa Kamal. My method number is AE1900089. So today I will present for activity 4 in lab 6. So I use load for 100 ohm and 0.01 for inductor. And then when I run the simulation, I will get for the wattmeter 49.9 watt, and then I change it to VA, and then run again. I will get 50 VA. So this is the data that I have obtained from the simulation before. So for impedance, I calculate using this formula. And then for simulated apparent power, I got it from the simulation before, along with simulated real power. And then after that, I calculate the power factor. So power factor is calculated by using this formula, real power divided by apparent power. As we can see here, apparent power is 50 and real power is 50. So when we divided it, we will get the power factor is 1. So we can see that when the resistive and inductive load is connected, the power factor obtained are more than 0.95. And so yeah. And then when the power factor is obtained as 0.1, it means that the number of watt consumed is same as the number of VA consumed, which referred as unity power factor. So that's it from me for activity 4. Thank you.
Hi, Assalamualaikum. My name is Nur Amira binti Saini with card metric number is AE190047. So now I will presenting the conclusion for this experiment. So based on the activity given, we can identify and verify the method of measuring DC and AC single phase power by using a wattmeter in Porter software. Besides that, by using Porter software, we get to learn and clarify each of component that need to be used for the circuit simulation. From the simulation and result obtained, we can measure the voltage, current and power for different value of resistant load given in simulation and value from calculated manually to get the correct value. So from that, we can identify the difference and we can compare the result between the simulation and value that calculated manually. In a nutshell, from this activity, we get to learn the power factor analysis from AC single phase power measurement. Thank you.